All right, what's up guys? So today we're actually going to start machining on our custom Titans and CNC grip that we're making for this double stack 1911. Now, obviously this is the one that we modeled ours after. We put out a video where we scanned this part and then we reverse engineered it, modeled it up, and then added our custom touches to it. Now I'll show you that here in case you guys haven't seen that yet. This is what it's going to look like. Now we put that video out as well as a video before the break that we kind of talked a little bit about the process that we're going to use in machining this. Well, today we're actually going to make it. And I also got a really exciting thing to show you guys, some software that I've been using for the last couple months that I really love. But for now, we're going to go ahead and get this thing thrown in the machine. So I've already got the dovetail done. It's just a simple dovetail, nothing big there. So to make this part, we're using 7075 aluminum. I've got a stop set up so I don't have to retouch my work offsets. I'm going to end up making 15 of these. So repeatability is key on this. This thing was actually really interesting in the fact that it presented a lot of issues depending on how you process it. So things like clearance issues or rigidity and even fixturing, you know, how we're going to hold this on the second op really played a big part into how we're going to process this. So let's take a look at how we're processing this and talk about some of those challenges that we're going to run into with this part. All right, so while that's running, we're going to go over here and we'll see what I'm talking about. This thing's just going to kind of rough out using that 3/4 inch end mill. I go all the way through and I rough all of it out from one side. Then I start stepping up. What I do like about this strategy is, to me, it's the quickest way to remove material for the most part. You know, there's obviously some parts that's not going to be true. One thing I like to do with my roughing passes on something like this, where I know I'm going to have a lot of small scallops that I'm going to be dealing with as it steps up, and really small step overs, is I'll start breaking this roughing pass into multiple operations instead of just doing it all in one op. So you can see right here, this first roughing pass, I'm going just full depth, no step ups. That's because with that full depth and the part is sticking so far out of the vise, and you might hear this when it goes around this outside, it's going to be a lot for me to take a huge radial depth of cut. So I'm going to tighten that up a little bit, not take such a big bite, but I'm going to go really fast. So I'm going 500 inches a minute here. So when I step up to these smaller sections, say like that right there, that's what's going to be left. Something like this. Well, I see all of these small movements, and plus I'm using a real small end of the tool, or not a big axial depth of cut, what I'm trying to say. So what I might do there is increase the step over. So that's why I separated those two tool paths. So I'm still going that fast 500 inches a minute, but now that I'm not cutting so much and I don't have so much pressure on this part, I'm actually going to increase that step over. I'm actually going to double it from what I was when I was going full depth. All right, so after we get it kind of roughed on both sides, we're going to come in with a 27/64 drill and drill through the top while this is a flat surface. And that's going to be for my 1/2-13 tap. That's going to come in after this rest roughing, and that's simply for the fixturing on my next operation. So we'll get there later. After the 3/4 tool runs, we're gonna step down with a 3/8 end mill. And I'm gonna rough out the top of this. I'm trying to limit only roughing and finishing on the inside exactly what I need to. That way we can leave as much stock as possible for Trevor on the EDM. You know, EDMs do not like really small cuts or like any cuts that are less than the wire diameter. So we always tried to hold like a 100 thou stock. That's a little bit excessive, but really you need enough for the thickness of the wire and then a little bit extra to keep the material from being so flimsy. So I don't want to just go and start roughing all this as much as I can, because the EDM is going to take care of all that and leave one nice slug coming out of there. So we're going to do some rest roughing with that 3/8 end mill. We'll get down here in the trigger guard, rough through that. And then we'll come in on this back side, start roughing out this slot through the back. So once we get that done, I'm going to come in and chamfer our 1/2-13 hole and then come in and tap. So this is what we're going to be left with after that first initial roughing operation. Now, I knew this file was going to be extremely big, so what I ended up doing is I broke this up into separate files just so I can keep this thing as fast as possible. So that's going to be it for the roughing. I'm going to open up this second file here. Since I'm using such a small tool on these eagles, I don't want to leave a bunch of scallops or mismatched material. I want it to be a consistent finish, but I also don't want to load up that tool. So what I'm going to do is I'm going to come in and do some semi-finishing. So I'm going to take that same 3/8 end mill that's got a 30 thou corner radius, and I'm just going to deck this side using just a 2D area mill, but then it's going to come in and kind of surface mill around the outside of these eagles, leaving about a 5 thou stock. What I ended up doing to make this easier is I created some surfaces on the outside of these eagles following that shape. So I drove that, and then I left 5 thou stock on that, because the tool that's going to come in to finish is going to finish the top as well as the bottom, or the in between the eagles. So it's going to do all of it so it's all consistent. And these eagles are about 15 thousandths proud. So I'm just going to follow along all the way around this tool, that 3/8 end mill, semi-finishing all of it. That way we got a good consistent amount of material around the outside. So that's kind of what we're going to be left with. After that, I'm going to come in and ream this hole. So probably could be drilled, but I'm just going to go ahead and ream it. And then we'll come in and finish the top. I'm going to do that with a 1/4 inch end mill. And then I'm going to come in and finish this outside, and I'm going to hold that to a tight tolerance. I might talk about that a little bit when I go to measure this, but I'm going to make a mag well for that. So I'm going to hold it to a tight tolerance. We'll swarf mill this bottom little angle, and then we'll come in and start finishing around the trigger guard. So I'm going to do that all with that 1/4 inch end mill. The main reason for that is, number one, it's small enough to fit in there. But number two is when I finish this top and I measure that with my micrometer, I'm gonna hold it to a tight tolerance. So I know when it's set here, it should be set down here. I'm gonna leave the same amount of stock and I'm going to do the same type of finish pass. That way I know I have the same load on the tool as up here. The only difference will be it might cut a little bit more material as far as axial down here, so there might be a little bit more tool pressure, but nothing that a spring pass can't take care of. Next, I'm just going to come in and start finishing some of these fillets. And then after that, we're going to come in and start finishing this slot. Then I'm going to come in with a keyway cutter for this groove, and I'm going to use a horn tool for that. One thing I want to show you guys is on this little leaf spring slot, I'm going to do like a chain drilling type tool path here, because I'm going to have to use a really small end mill for this. I think the end mill is 47 thousandths. So what I'm going to do before I come in with that end mill, where it's going to be more of a radial force, is I'm just going to drill as much material as I can with the drill, so it's all axial force. And then I'll come in with the holes in between and drill out in between these holes, so the material that's going to be left is right in the tip of the tool. I never want to do this in a way that, like, if I did it consecutively and I spaced them so close together that the tip of the tool is not actually cutting material, it's actually off in the air. You do not want to do that. You want that tip of the tool always engaged in material. So after we do that, we can come in with our end mill, and I'm just going to just ramp down and finish that slot out. After that, I'm just going to come in and rest rough these top fillets, this leading edge into this mag well, and I'm going to come in with an 1/8 inch ball surface milling it. So we should be left with something like this when we get ready for our eagles. Now again, I'm leaving all of this down in here solid. I'm going to end up coming in and roughing this out, but I'm trying to leave it as solid as I can so it's as rigid as possible. So then after all of that, we'll come in with our finishing tool to finish our eagles and basically all of this surface milling. Now I could have made this a lot faster if I'd used a bigger tool in some of these areas, but then I would have to worry about mismatch or trying to mash these together or blend them together and all that stuff. I didn't want to deal with all that. I want this thing to be as seamless as possible. So I'm really going for quality and an aesthetically pleasing part here, more than I am the most efficient thing you've ever saw. So keep that in mind, guys, when you're looking at this process and how I went about finishing that, because it's going to take a while, I can guarantee you. I'm going to use a unified tool path in Mastercam, and I'm going to start finishing this out in sections. Now you can see how we come down to basically a sharp corner on some of these places that I'm not going to be able to do, obviously. There's going to be some type of radius there. So that's another reason why I went with the smallest tool that I feasibly could. Now in this case, I'm using a 1/16 tapered ball nose to do all of this finishing. So I'm going to finish around some of these fillets, these blends. Personally, I like fillets more than chamfers. I think it's a cleaner look. So that's why I put fillets on this design instead of a chamfer. And then we'll get into the eagles themselves. If you guys remember the drum video I did where I talked about a clean core strategy, that's exactly what I did here. So I created a simple radius surface, and then I projected that onto the finished model. And by doing that, it was much easier to drive that tool and get me a cleaner tool path. So as you can see here, I'm just doing the flat section, then we come on around, and I just kind of started on one end and I went all the way around the part. So after we do that, we finish it with that 1/16 tool. You might can see this on here, but you're gonna be left with something like this. It's not gonna be this drastic, but you're gonna be left with something like this going around these eagles. And I didn't really like that. I wanted it to be really clean. So what I ended up doing is coming in with a 1/32 ball nose, and essentially I did a contour around these eagles. And I just did a few extra passes. I think I did 5 passes in total to get rid of that full scallop left behind on the 1/16 tool. And did a really small step over there. Now for the eagles that are on the radius, I did use a swarf milling tool path for that. So it's actually going to swarf mill around here. That way it keeps that pattern as close as possible to the original model itself. Now obviously guys, this is modeled with a straight wall, and the 1/32 is going to leave us a fillet around here, but it's going to be so small you're not going to be able to really tell unless you put a microscope on this or some type of magnification. But I think this is going to leave us with a really nice looking part once we're finished. The last tool that I come in with, it was a really sharp engraving tool. I think it was 30 degrees included, with a 5 thou radius on the bottom. I wasn't able to go all the way to the floor surface with that without cutting into our eagle by a lot. So I come up as much as possible, and basically I did it as a chamfer. And as far as the naked eye goes, that's going to be extremely small to see. So that's going to give us plenty of contrast between the body of the eagle, the head, and then the part itself. So I think it's going to look really nice. So like I said before, the 3 main factors that come into this was clearance, rigidity, and fixturing, you know, how I'm going to hold it for the next op. So if we take a look at this, there's a couple different ways that we could go about this. You know, if we make it angled, you know, then I'd have to go with bigger stock. So I was trying to limit the stock size so it cut down on the cost. But if I hold it like this, you know, there's going to be some things that I can't reach that I really wanted to from this op. This actually looks like it would be better on the surface because I could actually get more of these critical features all in one operation instead of splitting them up between 2 ops. Ultimately, I decided against that because number one, you would be machining all of these critical components out here at the top, basically unsupported. One of the big reasons why I didn't do this is because of this pocket right here, this open slot. Now you can see how close I would get to this vise in trying to bring a tool in here. So if I go in here, I'm not going to be able to check this from one side. So I didn't like that, but I really wanted to keep away from holding anything that was finished and visible to the person that is going to be using this as an end product. You know, I didn't want to mar it in any way. So all of that to say, that is why I processed it the way I processed it, basically upside down like this. Now I tell you guys all of that because, to be completely honest, when I watch a machining video in today's world, it's because I want to see how they processed it. You know, where I'm at in my career, like when I see something online, I want to get in my mind how I would make that part and then see how they did it. So I really try to bring you guys that whenever I do a video and give you all this excess information, because I'm trying to give you a little bit of glimpse into why I do things. All right, so that's going to be it for the eagles. I've got a separate program that's going to finish this part out on this op. So at this point, I want to stop and go and start measuring all of these things that I cut, all of my critical dimensions before we move on. Past this point, we wouldn't be able to rerun anything if we had to, because we're about to come in and pocket this thing out and then tab it, which is the final stage of this op. So I want to come in, take all the measurements I need to take in case I need to rerun any of these tools. First thing I want to check here is this outside flange, I guess you could call it. So we're at 281.9. I programmed it at 282, and I'm holding myself at 282 plus nothing minus 1 thou. And the reason why I'm doing that is because I'm going to go in and design a mag well for the outside of this. You know, typically those are made out of stainless or something like that, and it's just to offer a little bit of extension. A lot of people in competition use these, and it offers a little extension of the bottom and flares it out a little bit. So knowing that I'm going to go back and make that piece, I'm trying to hold myself to a plus nothing minus 1/1000th tolerance. That way it all fits very snugly. So looks like we're dead on there. Go to our next measurement. I went ahead and reamed this because I wanted to. I don't know that it had to be extremely accurate. I reamed it with a 4mm reamer, but the pin that's probably going to go in this is going to be a little bit smaller than that. And it doesn't have to be super accurate because of the mainspring housing, and I'll show you why. So the mainspring housing is going to slide in here just like this. And as you can see, it's got a hole through it as well. And this hole, all it's doing is holding this mainspring housing in. Well, the thing is, this mainspring housing has a hole here for the spring to go in. And on the bottom of that spring, you'll have a pointed pin, and it will go all the way through this. And probably can't see this, but there's a really small hole in there where that pin will stick through. And the pin that goes all the way through this side will have a little groove in it. So that spring is going to keep tension on the bottom of that pin. And that's what's going to keep this pin in. So I don't think that my hole really had to be that accurate, but just in case, I reamed it so it would be super accurate. The width of this groove in here, I've got some gauge blocks to check that. This is 143, so it's 543 thou. It's right on it, and looks like it feels pretty good. So again, I don't know that this has to be super accurate. I am going to try to hold myself to a tighter standard, but more importantly, this is something you kind of think of when you're building fixtures or you're doing second op or third op on things. I may have a big tolerance on this in real life. Maybe the print has a larger tolerance, but what I'm doing is I'm actually holding myself to an extremely tight tolerance on this, because I know that Trevor is using this groove to essentially locate on the EDM. So knowing that, if I make this too small, it's not going to go on his fixture. So if I make it too big, it's going to be able to move around and it's not going to locate very accurately. If you're going to use that feature in another operation, you might want to hold yourself to a tighter tolerance, which is exactly what I'm doing here. Now I'll take some calipers and measure the overall width, make sure that's good. Sorry guys, I know this is a little awkward. I'm trying to measure this so you guys can see it, but 629 is my nominal. I know this is calipers, using the ID portion of the caliper, so it's not the most accurate thing in the world, but it's close enough. There's plenty of clearance in there with the mainspring housing, the way it's designed, so I know I'm pretty close there. All our checks are done. We're going to run the next program, so I'm going to go ahead and do the heavy roughing on this op before we come in and do our tabbing so we can break this off. All right. So you've probably noticed that I haven't really been too concerned with the machine running in the background while I've been explaining a lot of this stuff. And that's because I have a new software that I've been running for several months now that gives me the confidence that I'm not going to have much issue at the machine. And that is called Run My Virtual Machine from Siemens. So what this is a virtual digital twin of my exact machine that gives me full 3D simulation and collision avoidance. And basically I can run the entire machine just like I would in real life. You can see here, I've even got the same exact buttons that I have on the machine. And what I really like about it is that it's a full 3D simulation and collision avoidance. Not only is it running off the code, it's running off the exact parameters and PLC of my machine itself. So the biggest problem with a lot of simulation and CAM softwares is that, number one, a lot of them don't run off the code itself. And two, even if it does, it still has to make certain decisions that may not necessarily line up with the decisions that your machine makes. Where this is literally using the NC kernel from the machine and is going to be a one-to-one just like my machine runs. If you're somebody like me that you like to see simulation and you want to know that this code is good before it ever makes it to your very expensive machine, this is an invaluable software to have. I've been using this for a couple of months now and I've really fallen in love with it, and I thought this was a really good opportunity to show it to you. Now you can notice I'm taking it a little light with this op right here. I don't want to just go spiraling all the way down as deep as the flutes can go and then ball out. I'm trying to take it, I think, in about 1/4 inch passes, and that's just to keep the pressure really minimum. So you know, as we're cutting that down, it's hollowing that out and we're not holding on as much anymore, so I'm just trying to keep that pressure as low as I can. All right guys, so I just paused it. This is going to be the very last pass that's going to make our tab. It's only going to be 10 thousandths thick, so watch this part really closely and watch what happens. Don't. That's my favorite part. Then you get the 5-axis wobble. So there's definitely no going back and rerunning the tools this time. This is a custom Titans of CNC limited run of a double stack 1911 that we're making for our good friend James Hampton with Paradigm Arms. James is a former Marine who turned entrepreneur and started Paradigm Arms. This grip is for his first development, which is the Alpha 1. But dude, this thing's looking really good. That's going to do it for this op, obviously. And you'd be surprised at how well these tabs hold. So if we take it, that's what we're left with. So you can see we got the bulk of the material out right here, but we still got to come in, rester up this, finish this inside, finish this top, because I left 25 thousandths of stock all the way around this outside. And then we'll get it over to Trevor on the wire so he can finish this mag hole. I'm super excited because I can't wait to see it done. So make sure you're subscribed and you hit that notification bell so you don't miss that video. We'll see y'all in the next one.
This is only the beginning.